Okay, today we're going to look at polynomial long division. In your book, if you look in your book in section 3.2, it actually does synthetic division. I never learned synthetic division. They didn't teach it when I was in school. I just did long division. If you know how to do synthetic division, that's completely fine. If the problems say solve them with long division, you can just solve them with synthetic division. It doesn't matter. I don't care. You just need to be able to solve the problems. But I wanted to go over at least one or two regular long division problems for those who either haven't seen it before or have maybe forgotten it and kind of work through it. It can be a little bit messy, but the good thing is, if you can do regular long division with numbers, then you can do long division with polynomials. It's the same thing, it just looks a little bit different. And what I mean is, suppose you were doing this. 412 divided by 4. If you were in like third grade, whenever they teach that nowadays, you would say what? How many times does 4 go into 4? 1. So you put a 1 on top. 1 times 4 is 4. Then you subtract. Then you bring down the next term, the 1. You say how many times does 4 go into 1? 0. So you put a 0 on top. 0 times 4 is 0. Then you subtract. 1 minus 0 is 1. Then you bring down the 2 and get 12. How many times does 4 go into 12? 3. You multiply 3 times 4 is 12. Subtract, you get 0, and then you're done. And your answer is 103. And you can check it by, since you're saying 412 divided by 4 is 103, you can do 103 times 4 is 412. I'm aware you can all do that. Polynomial long division looks messier. It's no different than that. It's the exact same steps. It's called the division algorithm in math. It's division. It always works the same. So, to start off with, suppose we want to do this one. X squared minus x minus 6 divided by x minus 3. One thing I'll actually say, when I normally do this in class, I like classrooms with whiteboards, which I know don't seem to work well with videos, but I like whiteboards because I can do this in multiple colors, so it's easier to see the steps out and how they relate to the steps over there. But just bear with me on the chalkboard, and I'll make it as clear as I can. Over here, we started by saying, how many times does 4 go into 4? Or, put another way, what do you multiply 4 by to get 4? 1. So do the same thing here. Start with the leading term. What do you multiply x by to get x squared? X. Put it on top, and the one difference with over there, don't line it directly above where you started. Line it above a term raised to the same degree, the same power. We're using x, put it above the linear term, the x term. It keeps things more organized. Now, the next thing we did over here was multiply. 1 times 4 is 4, put it down there. So do the same thing here. X times x is x squared. Now there's 2 terms, not 1, but we're still just multiplying, so multiply both terms. X times x is x squared. X times negative 3 is negative 3x. Now, over here, once we multiplied, we subtracted. Do that here. This is the one tricky part that people tend to get confused on. We're subtracting, and essentially, we're subtracting all of that, which means by the distributive property, this negative has to be distributed into both of them. The short way of saying this is, switch the signs of both terms. That's what distributing a negative will do, switch their signs. This one's positive, make it negative. This one's negative, make it positive. Now actually subtract or combine them. X squared minus x squared is 0, just like over here, which is what we want. Negative x plus 3x is 3 minus 1, 2x. Now, bring down the next term, like we did over there. So bring down the minus 6. Now, go back to the beginning and do it again. What do you multiply x by to get 2x? 2. Put it above the constant term. Multiply. 2 times x is 2x. 2 times negative 3 is negative 6. Now we get to subtraction. Switch the signs of everything on the bottom. Positive 2x becomes negative. Negative 6 becomes positive. 2x minus 2x is 0. Negative 6 plus 6 is 0. We have nothing left, and we're done. And our answer is x plus 2. And again, if you wanted to check it, you just multiply. But all of you know how to FOIL. X plus 2 times x minus 3 is x squared minus x minus 6. So we know it's right. The point here being, and we'll look at one or two more, this and this are no different. It's a division algorithm, it's the same thing. It looks messier because there's more than one term here and there's x's floating around. Principle is the exact same. So, suppose we have x minus 2 into, actually we'll do x minus 1 into x squared minus 1. Right at the start, well, let's see. We said the first step is, what do you multiply x by to get x squared? X. But then we said when we put the terms on top, you would put that above the x term, and there's no x term here. There are different ways to do this. If you want, you can just put it over here and kind of go from there. That tends to lead to confusion, so don't do that. So what we're going to do is, if we want to do x squared minus 1 divided by x minus 1, the first thing we do is look at all the powers of x here. Make sure they're all represented. What I mean is, that's x to the second, there's no x to the first, but then the constant is x to the 0. If all the powers are not there, put a placeholder in there, a 0, to account for them. So, x squared plus 0x minus 1. It's just a 0, so it's not really doing anything. It's just a placeholder to keep things neat and kind of organize everything for us. We might need the placeholder, we might not. We won't know until we solve the problem. So just put it in there just in case. Now do my regular division. What do you multiply x by to get x squared? X. Put it above the x term. X times x is x squared. X times negative 1 is negative x. Now it looks like we needed a placeholder, so that's good. Now, subtract. So switch the signs of everything. Positive becomes negative. Negative becomes positive. X squared minus x squared is 0. 0x plus x is x. Bring down the next term, the minus 1. What do you multiply x by to get x? 1. So put the 1 on top. Now multiply. 1 times x is x. 1 times negative 1 is negative 1. Subtract again, so switch the signs of everything. Positive x becomes negative. Negative 1 becomes positive. X minus x is 0. Negative 1 plus 1 is 0. And we're done. And again, I'm sure you all knew that x squared minus 1 was x minus 1 times x plus 1. But just keep in mind when doing this, if you're missing any powers of x, starting with the highest power you're given, just put it in as a placeholder. You may not need it, but you might. We're going to do one more. I'm aware that watching videos of people doing polynomial long division can be somewhat boring. So we're just going to do one more of these and work through it, and then we'll be good. Suppose we have x cubed plus 3x squared plus 9x minus 5. We want to divide it by x minus 1. Do the same thing. So we have all the powers of x cubed, x squared, x, and the constant, so we don't need any placeholders. What do you multiply x by to get x cubed? X squared. So put the square term on top and multiply. X squared times x is x cubed. X squared times negative 1 is negative x squared. Switch the signs of everything. Positive becomes negative, negative becomes positive. Subtract. X cubed minus x cubed is 0. 3x squared plus x squared is 4x squared. Bring down the next term, the plus 9x. Start again. What do you multiply x by to get 4x squared? 4x. So put it on top and multiply. 4x times x is 4x squared. 4x times negative 1 is negative 4x. Switch the signs of everything. Positive becomes negative, negative becomes positive. 4x squared minus 4x squared is 0. 9x plus 4x is 13x. Bring down the last term, the minus 5. One more time. What do you multiply x by to get 13x? 13. Multiply. 13 times x is 13x. 13 times negative 1 is negative 13. Switch the signs of everything. Positive becomes negative, negative becomes positive. 13x minus 13x is 0. Negative 5 plus 13 is 8. We get a remainder of 8. If you wanted to check this, I won't take the time to do it here. Well, how do you check it with a remainder? It's no different than checking regular long division with a remainder. Multiply this times this, and then add the remainder on. Make sure you get that. As far as the long division goes, I'm not going to take the time to do any more long division ones out because I think that's enough. There is one little trick, though, that can help us. It's what's called the remainder theorem. And essentially all it says is, if you take a polynomial and you divide it by something of the form x minus k, leading coefficient has to be 1. So x minus k, whether that's positive or negative, you can actually tell the remainder without doing the division. And all you do is, you take the k value, so in this case, if this is x minus 1, then it's x minus k. K is equal to 1. We've seen stuff like this before. The short way of thinking about it is if there's a negative in here, you switch the sign. So if this is x minus 1, then k is positive 1. If it was x plus 5, k is negative 5. You just switch the sign like we've done before. But now, to find the remainder for the problem, you just plug in k into this. If we plug in k, which is 1, we get 1 cubed plus 3 times 1 squared plus 9 times 1 minus 5. I know that just went off the side of the board, but you can all see it. 1 cubed is 1. 1 squared is 1 times 3, which is 3. 1 times 9 is 9, minus 5. 1 plus 3 is 4, plus 9 is 13, minus 5 is 8, which is the remainder we got. This is just kind of a shortcut trick. One of the things I would suggest you do when you're doing your long division, start, if possible, if it looks like this, x minus k, start by finding your remainder. Plug k in. Then do all the long division out. If the remainder you get when you do the long division is the same as the remainder the remainder theorem gives you, it'll tell you that you're more than likely doing it right. If the remainders are different, then something is definitely wrong. So you can use it as a little check or a guide to help you with your division. We're actually going to expand on this remainder theorem and what it does and how to use it in the next few sections in your textbook. So we'll come back to this. For right now, it's just a trick to help us with our long division.